Alright, this is an example of using the dot product, and the problem is to find the angles between two diagonals on the sides of a cube. So I have a little picture drawn here, and imagine if this was a six-sided cube, but we just want to know the angle between two face diagonals. So represented as vectors, this one would be vector A is equal to 1 x hat, 0 y hat, 0 y hat, plus 1 z hat. And vector B, this is A and this is B, is equal to no x hat, 1 y hat, and 1 z hat. So to find the angle between them, I know the dot product in two different forms. I know the component form, and I also know the analytic form, I guess. So I know that A dot B is equal to the magnitude of A, magnitude of B, cosine angle between them. So if I just convert this in component form, I know the magnitudes of these are square root 2 over 2 because that's what, or I'm sorry, just square root 2 because 1 squared plus 1 squared equals square root of 2. So for each side, I know that this is square root 2. And then that'll just leave the angle there. So on this side I need the dot product between A and B, which is simple. It's the x components times each other, so 1 times 0 is 0, plus 0 times 1 times 1, plus 1 times 1 is equal to AB, we know is square root 2 times square root 2 cosine theta. Then over here, these go away, and I just have 1 is equal to 2 cosine theta. So 1/2 is equal to cosine theta, and theta is equal to 60 degrees. And that is the angle between these two vectors is 60 degrees, and we just use the dot product to find it. Thank you, and let me know what you want to see next.